All right, we're going to be doing a different video than usual today. We're going to do a speed run of all of the definitions in the theoretical computer science class. So this should be fun. I'm obviously not going to make any edits to this. So what I'm going to do is I'm going to present the formal definitions of every single one of the objects we commonly talk about in the class. So let's go ahead and get started in 3, 2, 1, go. Okay, so a DFA is a deterministic finite automaton. And that is a 5-tuple Q sigma delta Q0F, where Q is a finite set of states. Sigma is a finite input alphabet. Delta is a transition function, which I'll give more details on in a sec. Q0 is the start state. So that is in Q, and F is a set of final states. The transition function takes 2 inputs, so something from Q and something from the input alphabet, and outputs a state Q, and this is a total function, which means that for any input Q and any state and any input character, we always have a defined output state. So it's a total function. It's not necessarily bijective. All right, so then an NFA is a non-deterministic finite automaton, and again, it's a 5-tuple, where Q input alphabets, start state and final states are exactly the same. So these 4 are the same as for a DFA. But the transition function now will take state and either an input character or the empty string, so that is for an epsilon transition, and it outputs a set of states, so it goes to something in the power set of Q. So, and you can say that this is a total function too, because if you have a transition that just doesn't go anywhere, then you define that to go to the empty set. All right, then a regular expression. R is one of the following 6 types. So this is over an alphabet sigma. So this is either the empty set, that's one case, just the empty string, just epsilon here, a single character for any character in the input alphabet, the union of 2 smaller guys, so R1, R2 are regexes, X's, the concatenation of 2 smaller guys, or the star of one guy. Okay, and it must be one of those 6 types. A regular grammar is a 4-tuple, so 4-tuple, I don't need to write that, so variables, terminals, rules, and start variables, so finite set of variables. And actually I needed to say that this is a finite number of applications. So a finite number of the recursive cases. So finite set of variables, finite set of terminals, finite set of rules, which I'll get to in a sec, and S is the start variable, which is in there. That's the start variable. And every rule in R is one of 4 types. It must be variable goes to epsilon, variable goes to a single character, where that is something in the terminal set. A variable goes to another variable. So for all these, A is a variable. Capital B is also a variable. Or it could be that A goes to a single terminal followed by a variable. All right, so those are all the ones that we cover for the regular languages. Now let's do the context-free languages. So a context-free grammar is, again, a for tuple. So these three, no, not that one, that one, that one are the same as for a regular grammar. And then rules, each rule in the set of rules is of the form variable. So A is a variable, and X is a variable or a character, as many of them as you want, and it can be zero labeled. So push down automaton is a 6 tuple, so Q, sigma, gamma, what are they? Delta, Q0, F. So my arms are hurt. So these 4 are the same as an NFA. Gamma here is a finite stack alphabet, and there's not necessarily a relation between between the stack alphabet and infinite alphabet. And delta is a function that goes from Q. The first thing is a state. The second thing is an input character. The third thing is something that you can push or not, and actually the definition depends on the book that you use. And then the output is going to be a set of state that you go to and thing that you push. Yeah, I did this backwards. Losing time. No one's ever done this. All right, so those are the context-free languages. Now let's talk about the final one, which is Turing machines. I think that's all of them. So Turing machine is a 7 tuple. So, and that is Q, sigma, gamma, which is not the same thing as a PDA, transition, Q0, Q accept, Q reject. So this, and these are the same as NFA. I don't go to gamma because it is different here. So gamma is a finite tape alphabet, where sigma is a strict subset of gamma, and the blank symbol is in gamma where it is not in sigma. So this is the blank symbol. Let's see, so we got that one. Q accept is the accept state. Q reject is the reject state. And we have that Q accept, and it's not equal to Q reject. All right, and then the transition function takes a state and a tape character that it reads, and it goes to Q cross gamma cross LR. The state, thing to write down, and which direction to move. All right, so that handles all of the objects. What about the forms and everything? Actually, there was one I forgot. So generalized NFA. Same as NFA, except start state, no incoming transitions. Single final state, no outgoing transitions. And 3, each transition is a regex. And in fact, you can do even more than that, but this is fine for our purposes. Chomsky normal form. For a CFG. Each rule of the form start variable goes to empty, so that's the first one. Second one, variable goes to a single terminal, so s equals start variable. A is a variable. Little a is in the set of terminals, and 3a goes to two variables, where b and c are variables. B and c are not the start variable. Let's see, what else do we have? NFA, DFA doesn't need it. Product construction doesn't need it. I can't think of any of it. CFG to PDA doesn't need it. PDA to CFG doesn't need it. Turing machine conversions don't need it. Encodings don't need it. And then I think those are all the objects or the forms in which we put things in. All right, so let's see. I can't see the time, but there you go. So that was a speed run, 100% speed run of writing down every single formal definition of either an object or a form in which something is put in the theoretical computer science class. Hopefully that was interesting. Leave thoughts about all of these into the comments down below. As always, please like the video and subscribe to the channel. It really helps us out. There are many other links in the video description if you want to support the channel further. And as always, thanks for watching, and I'll see you next time.